Hi everybody! So welcome to Math with Miss Kreppel. Today we are going to be doing word problems, everyone's favorite, with trig functions. So the first thing that I want to say is that most everything in real life happens like with some sort of trig equation, like high and low tides coming in and out all the time. That's a trig function. You can write it as a sine wave or you can write it as a cosine wave. Like this moon coming, like full moon, no moon, that movement is a trig equation. So most real things in life can be modeled with trig functions, heartbeats, things like that. So we're going to start with basics today and come up with some practical applications, and then you guys will be able to model all of your real life strategies with trig functions in the future. So one thing we just need to review is just how to write an equation if I'm given just a couple points. So we'll start with something like this. And as you can see, the way that this is written right here, it looks like a cosine function because it's starting here at a max. So if it starts at the maximum, then we know it's a cosine. In my opinion, it's a little bit easier to shift and work with cosine equations. And if you like sine, though, you can work with sine, and that's fine too. So let's say that this maximum value right here is up at 10, and this minimum value down here is at -2. And let's say that the period of this graph takes like maybe 5 minutes to complete a cycle of something, whatever this turns out to be. So what we're going to do is all of our trig equations today can be written in this form. A times the cosine of B times x minus c plus d. So when I write it like that, I know it looks really scary, but you've seen this before, and you know that A is the amplitude, B is the frequency, C is just the shift if you're going to move anything to the right or to the left. Now this one, for example, wouldn't need to be shifted right or left because it's already starting at a maximum. And then D is just what we're going to be shifting everything up and down. Okay, so the first thing that I like to do is draw a line right through the middle of these two things, and that's going to help me figure out what the vertical shift is. So I know that the total distance here between -2 and 10, that total distance is 12. So I just have to think in my mind, like, what's half of 12? Well, half of 12 is equal to 6. So that means I'm going to go up 6, and I'm going to go down 6. So this distance right here is actually equal to the amplitude. And then, if you want to think about shifting actually up to this dotted line, this is going to be your vertical shift. So if I'm starting at -2 and I'm going up 6, just add them together. So -2 plus 6 is 4. And that turns out to be your d value. So right now, if I was going to stick this stuff into the equation, I have most of it finished already. I know that amplitude is equal to 6. I know it's a cosine graph because it starts at the maximum. The b value we still have to figure out. There's no shift left and right because I'm starting right there at the x-axis or y-axis. And so I'm going to have to figure out that b, and I know that I'm shifting up 4. So to figure out the b part, it's not too bad. All I need to realize here is that the period is equal to 5 minutes. And I know that 2 pi over b is equal to the period. So remember that cool trick that we can just switch these two things? So 2 pi over the period is really just equal to whatever that b value is. So b is just equal to 2 pi over 5. So I write my equation like this. 2 pi over 5 times x plus 4. And now we're ready to work on a real word problem. So really the only thing that you need in these problems are either 2 maximums, 2 minimums, or just 1 minimum and maximum. So when you're reading a problem, that's really what you want to look for. So this is one of my favorite problems. It's the E.T. problem. E.T. Phone Home. Have you guys ever seen that movie? E.T. I saw it when I was in really little 6th grade or something. It was a long time ago. Okay, So researchers find a creature from an alien planet and they call it ET. ET stands for extraterrestrial. And then ET's body temperature varies sinusoidally with time. So sinusoidally doesn't mean that it has to be a sine wave. Sinusoidally means that it can be a sine wave or a cosine wave. You can represent it with that function or with sine. So here's the information now, the important stuff. 35 minutes after they start timing, his temperature reaches a high of 120 degrees Fahrenheit. So when they started timing, they realized 35 minutes later, they reached some sort of high temperature. And then 20 minutes after that, so 20 minutes goes by, so if 20 more minutes goes by, then I guess we just add these two things together and we're at 55 minutes. And then we're told that he reaches a low temperature of 104 degrees Fahrenheit. So what's going to happen is his body temperature is just fluctuating between this low and this high, up and down, up and down, up and down. So we have to come up with the equation, and then we can figure out at any time what his temperature is going to be. So we're going to put that on an xy axis. Normally we're always going to let x represent our time, and we are going to let, in this case, y represent our temperature. Now, I never draw these to scale, but what is really important is that you have to make sure that the 35 minutes comes first, because that's a smaller number, but it doesn't have to be exactly right. So don't count out 35 tally marks here, because it's going to take you forever. So at 35 minutes, we're at 120 degrees up here. So I'm going to put that little point right there. So 35, 120. And then at 55 minutes, we're at the low, 55, which is a low of 104 right here. Now in the example that I did in the beginning, it was a little bit easier to do because we had a whole entire period. But here, if I do something like that, that's only half of the cycle. So if this half of the cycle took me 20 minutes, then if I go out another 20 minutes, where am I going to be back at? Well, let's see, minimum, or maximum, minimum, and then 20 more minutes, I have to be back to the max, so that'll be at 75 minutes. I'll be back up here, if you like to see the whole picture. So there's a little period. Now I'm going to just go through the same exact thing, but unlike the previous problem that we did, this one's going to have to shift to the right. So all I have to do, the right shift, I'm just going to shift right to that maximum. And you can see how it's a lot easier to see how it's to shift to a maximum or a minimum. They're a lot easier to find with the cosine graph, versus if you're going to shift to a sine graph, you would have to find these points in here, which is not that practical. So I know right now that this right here, 35, is going to be my C value. And then I'm going to draw that line right down the middle. And then I find these two things. What's the difference between 104 and 120? Well, let's see. All I have to do is subtract them. So 120 minus 104. That difference is 16. So I have to split the difference. Half of it has to be above, and half of it has to be below. So I'm going to go down 8 from there, and I'm going to go up 8 from here. So that, as you can see, if you're going to be 8 above and 8 below, is going to be equal to your amplitude. Okay? So basically now we have the amplitude, we have the right shift, we have how much I'm shifting up, not yet. Here's something that's always confuses everybody. This distance from here to here is 104. I'm going to start here and go all the way up. So there's 104. This is where it's not drawn the scale. How much further did I go? 8 more. So the shift up is 104 plus 8, which would be 112. Basically your minimum plus your amplitude. So if you want to think about it like that, all you have to do is find the minimum, that's not spelled right, minimum plus whatever your amplitude is will give you your shifting. So let's see if I can write this. We'll erase this one that we had last time. So my amplitude is 8, cosine. I haven't found the b part yet. I always do that last for some reason. So x minus, I'm going to have to shift 35 to the right. I have to shift up 112. And then to find b, my period here is how long? 20 plus 20, so my period is 40 minutes. So my b value is just going to be 2 pi over 40, which is really pi over 20. So here would be ET's body heat equation. 8 cosine pi over 20 times x minus 35 plus 12. So now remember here that x stands for time and y stands for ET's body temperature. So then you can use this equation to say maybe, what is his temperature at 100 minutes? So then you would just have to plug in 100 here. So then you put it in your calculator. This is not going to be on your unit circle, so don't freak out. So 100 minus 35 plus 12, and then just put this into your calculator. That whole value. You can tell me what you get tomorrow. And then the maybe more difficult or maybe more interesting question is, when will his temp be, I don't know, let's say he's going between 104 and 120, so when will he be at exactly 110 degrees Fahrenheit? Well, you have to keep in mind, remember this is a sinusoid, so how many answers to that are there going to be? Infinitely many. So we have to come up with some sort of way to find all of them without working on this problem for the rest of our lives, because there's other stuff to do. So let's see. I'm going to do this. 110. So now this is a y value, so I set it equal here. 8 cosine of pi over 20 times x minus 35 plus 12. Now, I really think that the easiest way for you guys to solve this equation would be to type it into your calculator and put this on y1 and put this on y2. And if you do that, you can come up with 2 answers. Oh, it looks like you would get one right here, and you would get one right here. And then what would you have to do to find all the rest of them? Oh, well, let's say this one turns out to be 10 minutes. Then this next one would be 40 minutes later. So 10, 50, 90, something like that. But this is something that you guys can do tonight before you come to class tomorrow, is answer this question with your calculator and this one, and we can talk more about the solutions tomorrow. Have fun.